Alrighty, everyone. This is meteorologist Timmy Albertson here with you guys for tonight's weather chat. We got kind of an interesting one here. We're seeing very above average temperatures in parts of the upper Midwest this evening, and so we'll take kind of a little bit of a look at that. We also have Tropical Storm Philippe, which has actually made a little bit of a landfall this evening, albeit, folks, it's not very strong right now. So with that in mind, let's go ahead and start off with the tropics here really quickly. This is Tropical Storm Philippe. That's the satellite imagery below. Does not look the best. Well, part of the reason for that is it is running into a lot of wind shear. And as a matter of fact, it might actually be very hard for you guys to see it here on this particular imagery, the satellite imagery below me here. But the circulation of it, the low-level circulation is actually further to the northwest than a lot of that bright white and purple color that you see there. Those are higher cloud tops, basically thunderstorms. So what's interesting is that Philippe has actually made a landfall over the island of Barbuda. But the interesting thing is that a lot of the shower and thunderstorm activity with it is not anywhere really close to Barbuda at this time. So mainly just some passing clouds here and there. What is Philippe going to be doing? Well, Philippe has really been having a hard time with the whole wind shear. And that has really hurt it quite a bit, as a matter of fact. Now, as we go our way through the next couple of days, we are going to see Philippe kind of making its way to the north and kind of to the northwest, passing mainly north of the Leeward Islands there. And then it'll maybe make its way close to the island of Bermuda by the time we get towards the end of the work week. But again, it's still probably going to be running into a little bit of wind shear. And there is some uncertainty still, even with Philippe's intensity as we go forward through the week. But it is looking like it might actually get a little bit stronger. Maybe it might actually become a hurricane. So Philippe, which has been just hanging in there, even though it's been getting beat up quite a bit over the past, over a week, pretty much it's looking like it might actually have a chance to maybe intensify just a little bit, but it's mainly going to be staying out in the open waters. And eventually it might get kind of picked up by an upper level trough, maybe as we go towards the end of next weekend. But that's just kind of what Philippe is expected to do right now. Just a tropical storm right now, 50-mile-an-hour winds. Most of the convection is located to the south east of the actual center. So again, it's a very wind-sheared type of storm. All right, there's that. Now let's get on to a topic that, we're in the beginning of October, and we're still seeing some pretty warm temperatures in parts of the upper Midwest. As a matter of fact, there's quite a few locations this afternoon that are getting very close to reaching their all-time, or at least a daily record high value, or possibly some places, maybe even some of the warmest temperatures for the particular month. Again, a lot of that is up across parts of Minnesota, Wisconsin, and over in Michigan. Now, it's actually warmer down to the south across parts of Nebraska, but it's not quite as close to record-breaking values there, which is why you don't see those brighter red colors there. This is just one particular map of just locations that are getting close to their record highs. And again, some of them actually kind of already reaching at least daily record highs for this day. And folks, it is a rather warm one, as a matter of fact. So let's go ahead here, and we're going to take a little bit of a look over at the radar here. We'll flip the screen over, and let's take a look here at some of those temperatures here. Might be a little hard for you to see on your screen, but up around where I live, right across the bay there from Duluth, I live up over in the Superior area, and it is in the mid-80s right now in Superior. So what's actually really interesting about this here, and for those of you who might not live around this part of the United States here, you're going to get a little bit of a geography lesson. And folks, you can entertain your friends with this at a party. I'm sure you will be the life of the party. But normally when we talk about Lake Superior and the effects that it has around where I live, it's normally, cool temperatures, kind of get this localized high pressure over the cooler waters of Lake Superior, and that actually does kind of bleed in a little bit to parts of the land and can actually make it noticeably cooler. As a matter of fact, yesterday, places were in the upper 70s and even lower 80s around the area, but where I live, it was in the lower 60s, and it was cloudy. But today, the winds have managed to kind of overcome that a little bit. And I want to show you guys something that's actually kind of cool here. And we're going to take a look at the elevation layout of the area that we're talking about. So if we go about 25 miles south of Superior, Duluth area, the elevation actually increases quite a bit. It's about 1,300 feet, as a matter of fact, when you go about 25 miles out. As you travel northwards, though, you can see the elevation just quickly drops off. So what's interesting about this is you can imagine in the wintertime, or honestly most of the time, you have the cooler waters of Lake Superior, and it filters into this area here about 10-15 miles inland, at least in this particular direction here. That cooler air oftentimes has troubles rising. Cooler air will not rise if there's warmer air above it. So a lot of times this creates what's known as an inversion in meteorology, where you have warmer air up top and cooler air locked down below. And that was what was happening yesterday when where I am was in the lower 60s, cloudy and foggy. But if you went to the higher elevations, it was in the 70s, even lower 80s yesterday. But today, this same area is noticeably warmer, as a matter of fact. So let's talk about that here. It might be hard for you to see, but over at the airport up in Duluth, the temperature there, 82 degrees. Okay, let's get a little bit closer though, and let's take a look at Superior, 85 degrees there. So what's going on? Why is it warmer all of a sudden closer down to the lake? Well, the Duluth airport actually sits back into part of this higher elevations. Not exactly this high up, but it does sit in what is known as kind of the uphill area now, or the hillside area. Anyways, what's happening is that we have a very strong southerly wind right now. Not a strong southerly wind, but one that is enough. And the air is making its way in from the south, and then it's dropping. Now, as air decreases in height, it begins to compress, and that causes it to actually warm. Interesting, huh? Sometimes why we see valleys getting very warm, during, on hot summer days, why sometimes these lower elevation areas can be a lot warmer. So what's happening is this air is making its way down, and it's also mixing a little bit. So this air is actually a little bit drier to a degree down across the lower elevations than maybe up towards the higher elevations. But folks, we're not really talking about that big of a difference. But that's part of the reason why it's actually warmer. Now there is, the general rule in this type of situation is that the temperature will rise about 3 degrees every 1,000 feet you go. Well, you see we have a pretty decent drop off, not exactly 1,000 feet, but if we kind of put in the calculations a little bit here and also take in some other factors, that's why it's about 3 degrees warmer down in Superior than it is up in Duluth, where it's only 82 degrees. So it creates this little localized type of situation. And you can actually see this in a lot of the Great Lakes. Erie, Pennsylvania, another area I'm very familiar with. I spent a lot of time in Erie. And they have the same thing. Where you get these downslope winds, all right? These winds coming in from the south. The setup around Erie is kind of similar to this, only not as extreme, but it's still, we have this high elevation and then it drops down towards the lake. And that will actually allow for that air as it descends to actually warm a little bit. And again, that's what you sometimes see in some of these parts of the Great Lakes, is that in some instances where the elevation is set up like this, it actually gets warmer. It's pretty weird, huh? Now, sometimes the air gets too warm or whatnot, and some other things happen. Lake breeze will actually kick in and push it all back a little bit. But in this type of situation right now, the Lake Superior is not really playing too big of a role right now, despite the fact that it's right there. But again, right now, that's the reason why it's a little bit warmer there. So some downsloping winds. So what's going on? Why is it so warm right now across parts of the United States? Well, let's go ahead here and we'll take a look here. I'll pull up the old upper level map here. Got to make sure I got it up here. Where is it? Where is it? Is it possibly in this other tab? All right, let's take a look here at the surface map. All right, we'll zoom out here a little bit and we'll take a look at this here on the radar too, a little bit clearer. But long story short, we have this area of high pressure, ironically, pretty much right over here, Pennsylvania, the area I was just talking about. Actually, that looks to be more Jamestown, New York, but you get the idea. This is a very broad area of high pressure. Not the strongest high pressure, but it's still a pretty strong high pressure nonetheless. It's very quiet, mostly clear skies across much of the East Coast, even going back into the lower Midwest. If you remember the way the air flows around a high pressure, it's a clockwise rotation, all right? And folks, that goes into things such as pressure gradient force and Coriolis as to why that happens. But long story short, in the northern hemisphere, the airflow around a high pressure is clockwise. So over here, the winds are coming in from the north. Down here, they're coming in from the east. Here, they're coming in from the south. All right. So now we got a pretty steady southerly wind. All right, let's take a look at the air profile higher up into the atmosphere here. And let's take a look at our good friend, the upper level chart. We got ourselves a very defined upper level ridge here. So this air mass is not only warm at the lower parts, but it's also warm higher up. So again, this is a rather warm air mass. And while it might not be the warmest air mass we've seen, it's enough to get the job done. So we got this little bit of a pressure gradient force kind of happening right here. We see the pressure is a little bit lower. We actually have the center of low pressure right up here across parts of Minnesota and also some down near the Rockies. So there really isn't a particular area of low pressure right now that seems to be kind of dominating. We just kind of have these waves of low pressure, but the main thing is this frontal boundary. All right, so we have this high pressure here, area of low pressure here, and you can see how these lines, these are isobars, folks. These are lines of constant pressure. Notice how they get very tight. Well, not very tight, but relatively speaking, you see how they kind of tighten up a little bit. That's a pressure gradient here, folks. So what you're seeing is some breezy conditions. And some of this you might not understand here. These are meter plots, kind of an old way of showing current weather conditions. We still use these in meteorology sometimes, but basically what you see right here, these little lines that stick out from these circles, those are called wind bars. And they actually point to the direction the wind is going, or I'm sorry, is coming from. So it's not like a weather vane where, the arrow points to the wind, the direction the winds are going. Here, these barbs point to the direction the winds are coming from. In this case, you can see all south. Where we start having more notches on these particular wind barbs indicates higher values of wind, and it does it actually in increments of 5. Little barb is 5, long barb is 10. So in this case, and it's done in knots because honestly, this is the only time you'll use knots, but that's not the point. The point is that it's done in knots. So we got about 20 knot winds, so about 20, 25 mile an hour winds. So not a strong breeze, but it is a breeze nonetheless. And this breeze is doing a couple of things. Number one, we can see that where the wind is originating from, at least nearby, it's coming out of the south, okay? So it's somewhat of a moist air mass down here, but it's drying out as it goes further north. Obviously, this is the plains. There's not really big bodies of water out there, so it does lose a little bit of its moisture, and it gets mixed around a lot. So you can see how the dew points do actually kind of drop off a little bit, relatively speaking. But again, it's got a lot of air moving here. And so while the temperatures up across parts of Minnesota, aren't necessarily as warm as they are down across Nebraska, it's still enough that we're probably going to be seeing quite a few daily record highs set and, maybe a couple of monthly ones set. I mean, folks, right now it is, let's take a look at some other temperatures here. So we got 82 degrees up in Duluth. It is 86 degrees down in Moose Lake. 86, folks, it's October 2nd. Now, if this was Ohio, okay, it wouldn't be that unusual, but I mean, folks, we're looking pretty far north here. This is actually pretty unusual, especially for this time of the year. I mean, these are like summertime temperatures. Remember when we were taking a look at the heat wave back in August? I mean, take a look at the temperature right now around Coon Rapids up near Minneapolis. It is 90 degrees there right now. Dew point 54 degrees. Look at those winds coming straight in from the south. So we just have a very warm air mass, not just in the lower levels, but also in the upper levels too. Now, what's going to be happening though is this is eventually going to start to move out. That frontal boundary will begin to move. And when it does so, it'll allow for an upper level trough to move in. We talked about the upper level ridge. Let's go back, folks, to our upper level chart here, and we'll take a look over at this guy right here. Folks, that is a very defined upper level trough. In fact, it might actually be, from the looks of it here, it's very possible that it's a closed upper level low. So now we're dealing with an air column that is much cooler. Now, maybe not at the surface, all right, because what's interesting is, remember when I said air compresses as it descends. So we got cooler air here, but again, it kind of will compress a little bit as it does descend, and it does actually warm just a little bit there, which is somewhat kind of the reason. A few other explanations aside, sometimes why we see sometimes the cooler temperatures on further back on this part when it comes to upper level troughs. Usually, not always, usually. All right, so there we go. We got this upper level trough here. So if we were to kind of translate this, I know you hear talk about the jet stream. Let's look a little higher up here, okay? Now we're going to look more closer to about 20,000 feet, if not even a little bit higher than that. Let's see here. We're about, actually, we're closer to 30,000 feet here. So these black lines that you see are lines of constant height. And whether we do things a little weird when it comes to upper level charts, we plot the pressure height. That sounds confusing. And to a lot of people, it is confusing. It takes a little bit of time to get used to. For meteorologists like myself, who deal with these every single day, it's kind of second nature to us. But basically, remember when I said, if you have a warm air column, all right, warm air columns tend to be tall. Cooler air columns tend to be a little bit more condensed. So let's take a pressure, all right, 300 millibars. If you had that at the surface, that would be absolutely one strong low pressure. But we're a little bit higher up. Remember, folks, because of gravity, air is more dense the lower down to the atmosphere that you get. Higher up, the air becomes less dense, so its pressure is not as great. So what we're plotting on this particular map as at what altitude is the pressure 300 millibars. Okay, what does that mean? It means that we're looking at the heights here. That's what these black lines are. So in this case, right here in the center, 9,240 meters above ground is where that height right there, that's where it's 300 millibars. If we go a little bit further to the east, we don't hit that value until we go higher up to 9,600 meters. So this is not necessarily a big difference, but I mean, we're talking about 1,200 feet difference at least. No, excuse me. Now let's see, we're actually looking about a difference of about 4,000 meters almost. So, you know, it's a pretty decent, or 400 meters, excuse me, 400 meters, not 4,000 meters. 400 meters there. So yeah, about 1,200, 1,500 foot difference. So again, not the biggest difference, but when you are air, that is enough of a difference there. So this blue color here is the wind. Now again, these are the winds at that particular pressure height. So there is your jet stream, all right? Normally when we show these maps, we don't show the pressure part. We'll just show the wind speed part. So we got air that's trying to move. Again, pressure gradient, because there's not as much friction at this height. There's still a little bit of friction, but not much. It's almost kind of negligible. Generally, when you see these height lines, you can just assume the winds are running parallel to them. And you can see that very well here in this particular map, how the winds are kind of running right along those lines of equal height. All right, so where am I going with all this? Let's explain that. All right, so we got a very warm air column up across parts of the Midwest, upper Midwest here. We got our jet stream that's back here, and we got our overall upper level low, and again, some somewhat cooler air back here. Now, this guy is eventually going to start moving. Well, I mean, it's been, you know, it hasn't really moved much over the past couple of days, relatively speaking, but it is likely going to start to track its way towards the east. As it does so, it is finally going to more or less start pushing this frontal boundary here. So why don't we go ahead and we'll just take a little bit of a look over at our good friends at the Weather Prediction Center here, and we'll kind of animate this here a little bit as to what they have in mind. So let's take a look here at the surface chart here. We'll zoom it in just a little. Actually, you know, we'll just go ahead and open it into a new page here. So there's our high pressure this evening. Here's our frontal boundary. Remember, that upper level low is right back here. As we go forward, you can see how that upper level low, even though it might be weakening, it's still enough to kind of get that front to start moving a little bit. And you can see how now we're starting to get this center of low pressure right here to become a bit more defined. Now we're going to start seeing that frontal boundary moving. So this is as we go into tomorrow morning. So scattered showers, thunderstorms, usually going to be right up along a frontal boundary, not always, but generally you get the idea here. So here's our high pressure. You can see that moisture, right? The way the air flows around at high pressure, even though the front's all the way back here, some showers and thunderstorms will still probably be trying to develop in a somewhat conditionally unstable atmosphere that's going to be down here. This is really cool, folks. So, and again, this is going to become more familiar, and as we get, you know, later into the season, fall, when these systems start becoming a lot more pronounced, this is going to start making a lot more sense, and we'll go into more detail about it here. But this is just kind of a quick little introduction here, really kind of glossing over a lot of other things that are going to be happening with this. So, but let's continue on here. So as we go into tomorrow afternoon, that high pressure kind of just stays where it is, but that upper level trough is going to begin to kind of move a little bit more to the east. You can see how this low pressure is now becoming a little bit more. In this case, folks, these are isobars, lines of equal pressure. We're not looking at heights anymore. Again, we only do that when we're looking at upper level charts. All right, it's the only time you're ever going to be dealing with lines of equal height. When we're looking at the surface and most other cases that involve pressure, these are isobars, much like a temperature map, folks, where, if it's in red, it's temperatures in the 90s. In this case, again, these are, you can think of it kind of as akin to that, only in this case, it's pressure. So we're not plotting temperature, we're just plotting the pressure here. So again, there's our system. What happens as we go into tomorrow night? You can see that low begins to track its way up towards the north in association with that upper level low. There it is. You can see as we go to about 48 hours from now, we're going to be looking into very early Wednesday morning by this point. Notice how that trough has now moved up towards the north. There's actually kind of a larger trough further up across Canada that it'll begin to interact with. But notice how that guy just begins to hang out across parts of the upper Midwest. These are going to be much cooler temperatures. As a matter of fact, it's looking like temperatures overnight lows in some of these places will probably be dropping down into the 30s. So again, frost is going to be likely. But this is not going to be until a little bit later on. So we still have to get that front to push through. You can see now how as that low moves to the north, kind of becomes more attached to that upper level low. And what's funny, folks, is keep in mind, in weather, everything is connected. So this low pressure itself, just the fact that it's moving, is influencing that upper level trough. And that upper level trough is influencing that low pressure. So again, that's forecasting, sometimes when the forecast gets tricky, I mean, we're not just forecasting for one thing, forecasting for multiple layers. And again, those all affect each other. Not just in one particular point, but across the whole thing. Now you can understand how computer models sometimes work. Again, they're calculating all of this and doing some rounding, and then sometimes things get a little out of hand. But overall, you get the idea. That cold front looks like it's going to be pushing through as we go into the day on Wednesday, at least across the upper Midwest. Then we have this kind of little secondary low pressure. These are not unusual to see. It's kind of a little second, kind of quick moving little, I don't want to say clipper, but, just quick little moving little low there. They'll possibly drag through, maybe kick up a few more showers. And it's most likely that we're really going to see those cooler temperatures behind this guy. Obviously, this will be cooler, but take a look at that. You can see how it just starts quieting things down. So that's going to be what we're going to be taking a look at as we go through the rest of the week, is we're going to watch as this kind of warm air mass begins to make its way out. Now, again, you can see how the pressure tightens up over here. Again, rain showers, thunderstorms, there's a lot that could be delved into. Unfortunately, we don't have all the time in the world to go into this. I would love to go into this, folks. This is one of my favorite things of meteorology. Hands down, it's these low pressure systems. These have always fascinated me. Just how everything lines up usually with these little guys here. So fun things, yeah. So probably going to see some showers and storms. Looking like we're probably going to be talking about some shower storms across much of the central U.S., especially as we go into tomorrow evening. Showers, thunderstorms. Looks like, according to their thinking over at the WPC, again, I haven't got a chance to talk with our forecasters who work in Wyoming, but or do the forecast for the Wyoming area. But it looks like they're, at least the WPC is expecting possibly a rain-snow mix around the Yellowstone area, of course, higher elevation. Over that way. So certainly very interesting. So let's take a look here over at the WPC's chart. And we're going to take a look at what they have. Now, this is for 6 to 10 days out. Oh, gosh. Yeah, this is the first time I've looked at this today, too. So I'm looking at this. Good. You got to be kidding. Right back into the upper level. Or right back into the above average. So basically what this is they're basically what they're doing is they're between October 8th and October 12th. All right, so this is 6 to 10 days out. If you average the temperature out, is it going to be above average or below average? Doesn't necessarily mean it's going to be hot. It's just how above average is it going to be. Where we see higher probabilities, which in this case is the darker blues and the darker reds, 9 times out of 10 that correlates to, well above average values. There's a higher confidence. Let's put it for you that way. in that situation. So it does look like, unfortunately, above average temperatures are going to be returning. And it looks like our little friend here, this trough, is going to move further to the east, and we're probably going to see some ridging once again turn back. So unfortunately, it looks like we're not going to be done at the above average temperatures across the upper Midwest. However, next week could be a little bit cooler than usual. Back out across parts of Pennsylvania, actually pretty much most of the mid-Atlantic there. And again, that'll be as that front and everything makes its way out there. So it'll be kind of interesting. So it looks like, let's see here, October 8th, well, that'll be, looks like maybe some cooler temperatures to some of those East Coast football games, at least relatively speaking. So let's go ahead here, and you know what, why not? Let's take a look at some temperature values for today. Huh? All right, now let's take a look over at St. Louis. Let's see how St. Louis did for the day today. Wow, they are still above average. That is crazy. So let's take a look here. This happened to be the tab I had it open at. So today they got to 87 degrees in St. Louis. 87 degrees. Their low was 63 this morning. That is about averaged 10 degrees above average. Let's go ahead, folks, and take a look over where I am. Flip on over to the Duluth Weather Office, and let's take a look to see how the temperatures out that way did today. All right, now we already saw it was pretty warm. See here, when this came out, it was at 4 o'clock, so my guess is this is not the high temperature. Might be hard for you guys to see here. Let me zoom it in a little bit. Sorry about that. So let's take a look here. This came out at 4 o'clock. So my guess is the temperature is actually going to be a little bit higher for the official high. I think they're sitting at what, 83 right now, 82, 83. Regardless, 22 degrees above average. If we take the high and the low, average it together, we get the average daytime temperature, which is 72. And that's a lot of times in climatology what we'll use, generally is we'll use the average temperature. There's a couple of reasons for that, but that's 22 degrees above average. Wow. That's very warm. The record high for the day today is 86 degrees. It does not look like Duluth will be reaching that, but as mentioned, they will certainly be close. Let's take a look here to see if we can't find, wrong weather office. Let's go back over to Duluth. Let's go ahead and see if we can't take one more look here over at, and someone's mowing their grass out there. That's how warm it is. It's October. I already put the lawnmower away. Let's take a look here, folks, at International Falls. Have you ever heard of that place? It gets really cold in the wintertime. Today they hit 87. That tied the daily record. 87. Goodness, golly gracious, 31 degrees above average. Whoo-wee. So sometimes these systems, especially in the fall, they can be a bit strong, and so it's not unusual to see, these kind of swings of above average and below average temperatures. But that's still, 30 degrees above average is still pretty decent. This time last year it was 64 degrees for the high, 43 degrees for the low. Wow, that is hot. Ugh. International Falls, folks. It's a place that gets like 40 below every day in the wintertime. 69 was their, my goodness. Even that low temperature, 69 degrees, October. All right, well, we have that. As a matter of fact, I actually want to see something here. Are we able to, with International Falls, let's see how they did. I want to see how they did last month. What was the warmest they got up to last month? And it looks like 90 degrees. So the warmest they got up to in September was 90 degrees. Kind of close to that value again for this month. Alrighty, everyone. Well, that is basically it. I know I threw a lot of information out there at you guys. Again, just kind of an interesting setup weather-wise, but it does look like these above average temperatures will at least be going away for a little bit as we go towards the end of the week and into the weekend. But unfortunately, they may try to return as we go into next week, but it might end up being more so out a little further off towards the west. But regardless, you get the idea. There's our frontal boundary, and we're going to have to wait for that cooler air, especially upper level cooler air, to kind of work its way in to really get this thing moving. So thank you all very much for taking the time to join me here on tonight's Weather Chat. Hopefully you found it interesting. If not, I do apologize, but there you go. All right, everyone, we'll be back here tomorrow evening, probably a little bit later than tonight, or than what we did this evening, but we'll still have one up tomorrow evening. Oh, give me 1 second. They got a severe thunderstorm watch way down, and oh, okay, never mind. Well, they did have a tornado warning down there, but they just canceled it. We're going to take a look at that, but I think we've gone long enough for the night tonight. That's in New Mexico and parts of West Texas. They got a little severe thunderstorm watch down there, again, kind of associated with that frontal boundary, and they're kind of at the edge of that upper level trough, which is kind of a good area sometimes if you want to see severe weather. There's some reasons for that there. So looks like some some hail there. They had one hail report. My goodness, they had a one hail report in Pecos, Texas. 2.75 inches, 2.75 inch hail. That is a big hail. That's about almost this. That's a big hailstone. That's about this. That's a big hailstone. That's kind of a duck and cover kind of thing. That'll dent your car. That sounds like something I would drive into. Oh yeah, some big hailstones. All right, well, Pecos, Texas. For those of you following at home, if you want to look into it, there you go. So that is severe thunderstorm watch that's right out there. Again, it's at the base of that upper level trough on the eastern edge. It's kind of a good area. Reeves County, 2.75 inch size hail. That was at 5:20. I'm assuming that is 5:20 Central Time. So that would make that. I believe they're in Mountain Time out there, so that would be 4:20 their time. So, anyways, that's a big hailstone. Wow. What else do we got here? What do we got? Some wind gusts, 68 mile an hour wind gusts. You know what? Let's take a look at it. Why not? Let's see what these storms are doing really quickly here. We were almost done. Those of you were almost done. But yeah, there's some good storms down there. Take a look at that. Let's see here, what's this guy warned for? Still big hail. And it has trail possible tag on it. Interesting. Let's go ahead here. These are somewhat supercellular storms, so they're mainly doing hail. It looks like if they rotate a little bit here, take a look at some of the VILs from this. Wow, those are pretty good. Probably not as high as it was a little bit ago. And let's take a look here at the velocity radar imagery. Here again, I just want to see. Let's take a look here. That's still some big hail. It's got a little mesocyclone in there and everything. All right, so for those of you who like hail, might be a fun area to watch maybe over the next hour or so. Again, this is Midland, Texas radar. There's the Lubbock radar. So again, we're looking far western Texas and going into parts of eastern New Mexico. I just can't get a 2.75 inch hail. That is a big hailstone. All righty, everyone. I think we've gone long enough for the night tonight. I'll let you all go. Let's see if we can get a bigger hail, though, from that area. All right, so I hope you all have a good rest of your evening, everyone. Look forward to seeing you back here tomorrow evening. Take care, everyone, and keep enjoying that weather.